is a good offense. It is a presentation about our API attack simulator case study. We are talking in the field of API security. When we talk about APIs and API security, we are mindful how APIs are the #1 attack vector today. Every enterprise that has an API is aware that their API is a very lucrative attack vector for attackers and needs to protect it. OWASP has published a list of the top 10 API security issues, and enterprises need to make sure that their APIs are not vulnerable to these vulnerabilities, that they do not have API security issues, because API security issues can allow an attacker direct access to the database, to the servers, to private user data. So it's a very important thing to stop and secure. The best way to secure your API is to find your vulnerabilities before the attackers do. This is what the Web Attack Simulator does. It attacks your servers under a controlled attack simulation and finds all the API security issues within your APIs. So what the attack simulator does is it targets the enterprise APIs, might have a few different domains, within each domain different routes that accept different parameters, and the attack simulator, installed either on-premise or private cloud or Web's cloud, sends API calls as attacks to every single endpoint, fires many, many different API calls and attacks, and finds the locations and the routes and endpoints in the APIs which are vulnerable. For example, suppose your servers have an API that consists of a login route that accepts a username and a password. The way the attack simulator works is it creates many session variations, many variants of calls against this API. For example, changing the username to a different value, changing the password to a different type, changing the route, changing the method, adding parameters, trying to add injections, adding headers, every possible variation against the API, checking which one of these variants of an HTTP request will generate a response or something that signifies a vulnerability at the API. We create thousands of different variations to cover any possible attack vector. We fire each one of these requests against the API. For example, in this example, we can see we fire a login, sending an array for a username and a null for a password, and we analyze the response for each request. By analyzing the response and knowing the logic of the attack that was executed, we can figure out if what we just triggered looks okay or is a vulnerability at the API level. By firing thousands of different all possible attack vectors and analyzing the responses, we can get the final list of API vulnerabilities, all the issues that are found at the API level that consist of API vulnerabilities. This is very important for the enterprise. They can take this information and use it to generate the remediations to fix their vulnerabilities. So by executing an attack simulation against your API, you can find your vulnerabilities before the attackers do and apply the necessary remediations to fix your code and API and stay secure. We will now dive into a case study that we had with one large client, Smart Home, a company that creates software for people to manage their homes efficiently. This is a very large enterprise. It's an S&P 500 company, and with them, we executed an attack simulation on their APIs and found very significant issues. We will now walk through this case study and observe what we did, understand how it can apply to every enterprise that has an API that wants to make sure its APIs are secure. So, Smart Home, a company that creates software for people to manage their smart appliances at home and delivers an API so they can use their app to remotely connect, get data.
Sella, sorry, we can't see the presentation, the correct slides. It's still showing the previous slide.
I think we're good. We can see the list of APIs.
No, we can see the vulnerabilities. You can see the slides. Great.
Yeah, we're good.
Okay.
So, Smart Home, for example, this is a company that creates software for smart homes, so people can connect to the API remotely and get information and manage their smart homes. Have a list at the left side of the screen. We can see a list of the routes they support. When we run our attack simulation, we not only connect to every route individually, but we also know how to need to emulate an attack that consists of a session. A session meaning a succession of HTTP requests that are connected between them. For example, a user that connects to the API, and this applies both to a legit user and to an attacker, first would call the login route and then receive a token. They would then use this token on subsequent calls for authentication. So a first call might be to a login route to receive a token, second call to create a new account new home entity with the token, receive an HTTP 200, and after creating this home, receive the ID of the home that was created. This ID would be used in the subsequent call to get the device's information of this home, for example. So this is a session of using the API, and the attack simulator needs to simulate an attack session. So the attack simulation performs a login, creates a home, gets the home information, and then tries to see what sort of variants and what sort of manipulations it can run. For example, one attack variant is once we realize that the URL includes an ID that appears to be a resource ID, we try to manipulate it and send a different resource ID and see if we can still access this data. In this case, getting a 200 HTTP response means we were able to successfully access the information of a home, but not the home we created, which means this is a vulnerability because we could access the information about a home that somebody else created. In the API security world, this is known as BOLA, Broken Object Level Authorization, where one authenticated user is able to access the information created by a different authenticated user. This is, of course, a very severe vulnerability at the API level because the implication is one user can access another user's private data. Of course, a very big problem at the API level. Another type of attack that we try to simulate is see what happens if we add illegal characters instead of the ID number. In this case, we saw that the server does not validate the input and does not validate the output, outputting an error message with information about the stack trace of the server, which gives an attacker further information on how to attack the server. Let's recap what we just did. We started with the session, indicating a session consisting of the correct usage of the API, calling a login, creating a home, getting information about the home that we created by its ID. And the attack simulator executed variants of this attack by changing. In the first attack, we change the home ID into a different home ID, see that we can access another user's created homes. And in the second attack, by sending illegal input as the home ID, we see that the server returns an error message with vulnerable information in it. So the first attack returned 200. This indicates a BOLA, broken authorization process. The second attack returns a stack trace with information about the technical implementation on the server side, which lets an attacker get critical information that they can further use to attack the servers. In this case, for example, the output stack trace included information about the type and version number of the server running. Old, outdated Apache Tomcat server, which the attack simulator can automatically cross-reference with known vulnerabilities and come up with the information that the server that is responding to our requests is vulnerable to known zero-day CVEs, including the ability to execute remote code execution, denial of service, and log4j. It is very important to focus on how each one of these vulnerabilities is publicly discoverable because the API is by design available to all consumers. It is meant to be consumed by the public, so anyone can attack the API and see these vulnerabilities. And once they find the vulnerabilities, anyone can exploit and use these vulnerabilities to hurt the company and get to the private data of users and the organization. This is the nature of API security issues. The API is meant to be consumed. It is meant to be accessed by the public. So it is very easy and dangerous for the public or attackers to find vulnerabilities in the code and exploit them via the API. So when we worked with Smart Home, we ran this attack simulation on their servers and automatically, as we saw earlier, executed thousands of different variations against all possible routes and all possible sessions. And we could use this process to find the vulnerabilities in their API automatically in a way that would let them find and fix these vulnerabilities before a malicious attacker would be able to do so. This is part of the reason and reasoning behind why an attack simulation is so important for an organization to run themselves and find their API security issues before attackers with similar technology might do so maliciously and hurt them. This concludes the frontal part of our explanation of what the benefits of an attack simulation are against an API, against an enterprise wanting to secure their APIs, and the case study of how we executed such a simulation with one enterprise. We will now open the floor for an open discussion for questions about what we did, how it worked, and how this would be valuable for your enterprise. So Tessa and Rafael, please join me and we can discuss this together.
So we have a couple of questions here. First one is, what pain point is being addressed by the product?
Well, the pain point is mostly that the API is a very salient attack vector, and it is very hard for security teams to make sure that their APIs are secure, and yet it is very important for them to do so. API security issues pose both very high risk and very high impact problems. They're very high risk because the APIs are publicly accessible and meant to be consumed and integrated with the public or other external clients. It is very high risk because the API leads directly, usually, to the database and to private data. So an enterprise that does not make sure their API is secured has a very high likelihood of suffering from a very deep and painful cyber attack that might be able to compromise the enterprise's operations and their private data of their clients. APIs are very easy to exploit, and it's a new frontier that requires a new technology, such as attack simulations, to find the API vulnerabilities before a malicious actor does. So any enterprise that is concerned about private data that is accessible by their API, which by the nature of today's internet is an extremely common and beneficial in other aspects of configuration, should make sure they run an attack simulation to make sure their APIs have been checked and are secured. And usually they're not secure, so it's important for the security team to find all the vulnerabilities and remediate them before attackers do and exploit it maliciously.
Yeah. Anshu Singh has a questions about, is this tool open source and free to use?
The tool is not yet open source. We are working on open sourcing it. However, in the meantime, it is available under license by WIB, the company. This is what we do. We lead the market in this aspect, and we are happy to work with enterprises around the world, which is what we do, to make sure they perform an adequate attack simulation, find their vulnerabilities, and remediate them before any malicious actors do. So right now, it's not yet open source, but we help enterprises integrate it and operate it and simulate attacks on their own APIs together.
Yeah, thank you. That was really, really precise answer. What would you see, what are the main challenges when there are legacy applications involved with APIs? So we know that legacy applications are a really, really big pain point for companies because they have so much technical depth behind them, typically. So
absolutely. Building an API and maintaining it is difficult no matter the stack. It is doubly difficult when the stack trace runs on legacy code. And even more difficult than that is always the disconnect or the cooperation, rather, between the security team and the development team. Because the development team has many issues on its plate and are not always 100% dedicated to the security issues. This is why it's important to supply the security team with tools that can scan, find vulnerabilities at the API level, and supply the appropriate remediation for the development team to make the operational efficiency of the organization top-notch. So make sure the security team can quickly find exactly what needs to be fixed, why, and how, and to assist them in connecting all this information with the development team to make sure they can quickly fix what needs to be fixed efficiently and securely.
Yeah. Thank you. Then we have questions about how are API specs evolving in terms of standards for different industry verticals?
This is a very good question. We are actually in the beginning days, historically speaking, of the API revolution. APIs are really transforming how the internet works, both B2B and B2C. In the past, we used to have server-side rendered websites, which gradually evolved into web applications. And today's standard is very thick, rich clients, both web single-page applications, mobile applications, smart TVs, and smart devices, who are all connecting with the business logic of a company, which is run on the server and exposed via an API. So APIs as a concept have really taken the internet by a storm and are becoming the de facto standard. They are becoming such a standard that vertical industries are developing their own API standards in order to enforce APIs that will allow greater interconnectivity both between players within the industry and with players outside the industry and consumers. Leading verticals for this include the financial industry, especially in the Open Banking Initiative, which is setting the standard for APIs across the world for open banking institutions to connect between themselves and with their clients. Such open standards help connectivity with partners and with consumers, but the focus on the APIs demands that the enterprise also allocates the appropriate resources into ensuring that the APIs are secure. Most organizations are gradually learning this, sometimes in parallel to hearing in the news of yet another organization with an API leak, an API security issue that has led attackers to compromise them, get their data, or hurt their users. So it is very important within every industry. The more you care about your data, the more you care about your users, the more you are relying on your API to expose your information outside, to make sure that you do not have API security issues. This is very difficult. How do you know if you have found all your API security issues? How do you know if there's an API security problem in one of your endpoints that an attacker is exploiting right now without your knowledge? For this, the industry, such as Web, are developing standard API security tools that can help both defensively, intelligently, and from an offensive perspective, such as an attack simulation, which is a cardinal facet of any API security strategy that any enterprise needs to emulate. So within every vertical industry, the need for an attack simulation exists to make sure that the APIs are secure and do not contain any vulnerabilities that can be exploited by attackers.
Yeah, great answer once again. Then there are questions about how do you track your API security and chain of events in complex microservice architecture?
Mhm.
So microservices are quite difficult in sense of security, but when you do it correctly, so it's a superpower.
Absolutely, absolutely. I remember about a decade ago when microservices started to become a standard for large enterprises in terms of how to manage the internal code base. Microservices, of course, all connect with each other and occasionally with the outside world via APIs. So this is one more instance of how APIs are transforming the way programs connect, the way developers develop, and the way enterprises connect with their partners and with their clients. So now that we are in the age of microservices from a backend architecture point of view, this means everyone is adding more and more APIs almost daily. In many enterprises with fast development velocity, APIs are added or modified more than once a day. It is impossible for a security team to stay on top of all the APIs that are added or changed every day and maintain their security using any sort of manual or bureaucratic process. For this, there is a need for dedicated technology to monitor the APIs and make sure that the API security is being maintained, even when the security person is out to lunch or not necessarily part of a pull request that updates an API. Some microservices often are exposed to the world via either an API gateway that consolidates all the incoming traffic or externally bypassing the API gateway. So API gateway was meant and is still meant and is a good strategy to help consolidate all API requests, which help enforce API security for the entire enterprise. But it is impossible for the entire enterprise to cover all the new endpoints that are being added, modified, and exposed, both internally and externally, sometimes bypassing the API gateway. For this, it is necessary to have a dedicated piece of technology and some attack simulation process to ensure that all the APIs of the enterprise are continuously being scanned and simulated for attacks, which is the API age equivalent of scanning for vulnerabilities in the attack surface of your code base and your product. So for this reason, especially in the age of microservices, any enterprise which already supports more than a single monolithic backend, any organization which is running with a microservices architecture is very likely using a high level of APIs, is likely using APIs every day, and the development team is likely modifying and changing APIs at a rate and cadence that the security team is not and cannot be monitoring. And for this, in attack simulation, is very helpful to make sure that even if APIs are added, then that they're being scanned for vulnerabilities and that all necessary remediations are being applied before a malicious actor can exploit them.
Yeah. So we have 4 minutes left and some questions still remains. One of them is how well can API security be monitored, whether there are situational awareness solutions that can identify those threats to APIs?
Absolutely. The world of API security is new, exciting, and scary. Here at WIB, we develop systems for both offensive and defensive control and assistance to make sure an enterprise is adequately defending their API, that they have a full lifecycle solution for API security. It's very important to have really a full lifecycle approach and not focus only on a single aspect of API security to make sure the enterprise is defended at the code level, at the traffic inspection level, and running an attack simulation on the APIs externally to find all the issues. Oftentimes, from a defensive point of view, once an API attack is encountered, it is important to have the integration both in terms of alerts and integration with SIEM or other notification systems. Oftentimes, we also recommend connecting to a NOC or SOC to surface these alerts at real time, connect with a WAF or API gateway to block them in real time, and to have tools to monitor the API security situation and attacks in real time. Such a full lifecycle real-time approach is important to ensure your enterprise is defended and that the APIs you expose to the public are not being manipulated maliciously for attackers' gain.
Yeah, thank you. We have a couple of minutes left. I think I will take the final question and then your information. Best tools and practices to create fuzziness in API functional and non-functional verification.
Sorry, can you repeat the?
Yes. Best tools and practices to create fuzziness in API functional and non-functional verification.
Sure. So fuzzing is one main strategy to employ an attack simulation on an API and test it for problems. Fuzzing is the practice of taking different parameters that are sent to the API and trying to change them in a variation of ways, trying many different combinations. It is also sometimes referred to as playing with the API by trying different combinations of sending parameter values and types to see how the API might respond. WIB's attack simulator is one such tool, or rather fuzzing is one strategy that our attack simulator employs in order to cover all the possible attacks against an API endpoint. So fuzzing is the first strategy. We saw other strategies such as analyzing the response, trying to access unauthorized data. There are really many different strategies that an attacker might employ, and most important is probably to have an automated process which lets you scale the number of strategies that you employ. Such an automatic attack simulation tool, such as the attack simulator that WIB has as part of our suite for full lifecycle API security products and strategies, is part of what helps us make sure that an organization is covered 360 degrees in terms of API security.
I was also
in order to test an API and simulate an attack. Simulating an attack against an API is the first step in full lifecycle security, and making sure your APIs are secure is the first step in making sure that your organization is keeping your private data and your clients' data private and secure.
Yeah. So there is a question whether this this presentation will be available. So are you sharing your slides as well?
Yeah, absolutely. Please contact us at WIB, and we are happy to share our information with you and help you get your organization on the path to making sure your APIs are secure. The awareness of API security is rising gradually in the market, but it's important for you to make sure your APIs are secure before the attackers realize that they aren't. So contact us today. We're happy to share the slides and more information about both strategy and vision and the technical implementation of how to keep your APIs secure and help your enterprise stay secure today.
Thank you so much.
Thank you, guys.
Great presentation, Sella and Rafael.
Thank you, Tessa.
Thank you.